different quantities like voltage and current in both a star and delta connected system, right? So now today we will talk about this power measurement in a three-phase circuit, right? Means what are the different methods for the used for the measurement of power for the different configurations of the electrical network, three-phase electrical network. So all of you know that what is does this power signifies? So if we talk about power in a three-phase system, power in a three-phase system, then we have already discussed that the power, electrical power, is of three types. First one is your active power, which is represented by P, and its unit is in watt or kilowatt or megawatt. Then another component of the power, electrical power, is your reactive power, which is represented by, what is the unit of reactive power? Tell me. VAR. VAR. So if some power value is given, suppose 50 MVAR or 50 VAR, it means that you will have to understand that this is a reactive power. And if it is just 50 kilowatt or megawatt, then you will understand that this is a active power, right? Now the combination of these two is your total complex power or apparent power, which is your volt ampere, right? And this is your पावर फैक्टर एंगल थीटा और फाई वट एवर यू यूज. चलो हम लोग फाई ही यूज कर लेते हैं क्योंकि अभी तक फाई यूज करते आए हैं. सो दिस एस इज योर वोल्ट एम्पियर. सो इफ वी टॉक, दिस इज बेसिकली ए पावर ट्रायंगल, इसी को बोलते हैं पावर ट्रायंगल, राइट? सो इन ए सिंगल फेज सर्किट कोई अगर है, so in that your volt ampere, simple volt ampere or total apparent power, this is also known as total apparent power. So this is simply VI, right? Unit in volt ampere, volt ampere. ठीक है? Now if we consider a three-phase system or a three-phase load, then whether it is balanced or unbalanced, then the total volt ampere in a three-phase system, whether it is balanced or unbalanced, is basically the sum of volt amperes in each phase. तो मान लो कि एक फेज का जो है, एक फेज का है सपोज S15, so this will be simply 3 times S single phase, right? Volt ampere, this is the unit, volt ampere. So you can write it 3 times VP IP, where VPI is the per phase volt ampere. So VP is your RMS value of the phase voltage and IP is your RMS value of your phase current, right? So for a star connected system, suppose if the three phase circuit is first of all a star connected, then S3 phase means total apparent power in a three phase circuit will be 3 times VP. If we express VP in terms of VL, then VP is VL by root 3, and this IP is equal to IL in a star connected system. We have already discussed these things. This is your VP and this is your VL, and IL is equal to IP in a three phase system. So simply root 3 times VL IL. So similarly in case of delta connected also you can see that, in case of delta connected system also you can see that the total apparent power will be equal to root 3 VL IL. That you can do using the same relationship. In that case current will be changed, means root 3 times हो जाएगा, right? So this is about your total apparent power. Now, if we talk about just active power P, then you know that power in a single phase circuit is active power in a single phase circuit is Vi cos phi. You can also get this relationship from this power triangle. If you write the expression of cos phi, so cos phi will be P by S, where S is your volt ampere, that is Vi. So from there you can write the expression of active power in a single phase circuit having unit in watt. So therefore, in uh, a three-phase circuit for balanced load, this P3 phase will be equal to 3 times Vp Ip cos phi. इसका 3 times हो जाएगा single phase का if your load is balanced, because if load is unbalanced then the magnitude of active power consumed in each phase will be different, right? That all of you know. But here we have considered the balanced case. So now you can express this power in terms of the line values. So simply you will get root 3 VL IL cos phi. This is power in a three-phase circuit, right? Now further, if you talk about the reactive power, these are very basic thing. I think all of you know it. So Q single phase will be simply again from this triangle, power triangle. All powers are derived from this triangle only. Q single phase is equal to Vi sin phi. Now its unit is in var. So Q3 phase will be simply equal to 3 V phase I phase sin phi, or root 3 VL IL sin phi. Var, unit is var. So this is the different type of powers available in uh, electrical system, right? Now I have a question for all of you. You have to just do it right now, so that, or not so that, otherwise you will know the answer. Just uh, find the relation uh, between the power consumed by three identical phase loads connected in delta and when connected in star. मतलब एक थ्री मीन्स एक थ्री फेज लोड है विच इज identical, means all the phase impedances are identical in magnitude, right, as well as in phase angle. So when that load is connected in delta and when it is connected in star, then you have to find the relationship between, suppose P delta, means when the load is connected in delta configuration, then what is the relationship between P delta and P star when the loads, all the three phase loads are connected in star. ये बताओ कितना होगा? Use the relationship of this power in a three phase circuit. हेलो, हेलो, आवाज आ रही है?
Yes, sir.
हाँ, तो इसको कैलकुलेट करो. बताओ कितना आ रहा है, P डेल्टा बाई P स्टार।
Sir, 3.
राइट, यू विल गेट दिस 3। तो अब जैसे कि मशीन में अगर पढ़ोगे तुम लोग, अगर सिलेबस में होगा कि when you will study in electrical machine about the starters in three-phase induction motor, there you will find the application of this star and delta conversion. Means there is a type of starter, star delta starter, right? उसमें क्या होता है कि नॉर्मली द व्हेन द इंडक्शन मोटर, थ्री फेज इंडक्शन मोटर starts, so at the time of starting it draws a huge amount of current from the supply system, right? So starting current is very high, ठीक है। तो करते क्या है कि हम लोग पहले जो है सो स्टार में रखते हैं कनेक्शन स्टार्टर का। हेलो,
यस सर।
आवाज आ रही है ना?
यस सर।
Okay, so when the machine or induction motor picks up the rated speed, so in that condition the configuration is changed to delta, right? ठीक है ना? So when the configuration change to delta, then you can see that it can draw 3 times, means 3 times power demand can be fulfilled. और उसमें current का भी कुछ relationship होता है, that you will understand when you will study the three-phase induction motor starter. But for the time being, you just understand that this is the relationship between the power when the loads are connected in delta and when it is connected in star. तो जिसका नहीं जो कर पाए हो ये सॉल्व, ये खुद से ट्राई करोगे होम असाइनमेंट, देयर इज नथिंग, simply you have to consider the different quantities. Like let us consider here, this is your Vp phase voltage, then this is your VL, right? Here IL is equal to IP in case of a star connected system, and when you draw or reconnect it in delta, then means each phase had some impedance which is equal in magnitude. Let us consider it as Z. Similarly, the same load is connected in the delta configuration Z. Here you have Vp is equal to VL, and this is IL, this is I phase, right? ये भी IL है, and this will be again I phase. The direction may be changed, ठीक है, वो डिपेंड करेगा डायरेक्शन क्या होगा। तो बस इसी एक कॉन्फ़िगरेशन इसके लिए निकालो पहले स्टार कनेक्शन में, फिर डेल्टा कनेक्टेड में निकालो, and then just take the ratio, you will get this 3. Okay, so now we will discuss about the power measurement using 2 watt meter method. Means ultimately we have to measure or calculate the total power in a 3-phase circuit. So there may be different possibilities, like suppose using 3 watt meter also we can measure the power, then 2 watt meter also we can do that. Single watt meter can also measure the power of the entire 3-phase circuit. But it has been observed that this for a three-phase, three-wire system, whether it is balanced or unbalanced, a star-connected or delta-connected system, only 2 wattmeters are required to measure the three-phase power, entire three-phase power in a circuit, right? So this is the most popular method of measuring power in any three-phase circuit. Why? That we will study, because there are certain limitations to measure the power using single wattmeter method. We will discuss all these things, but first of all, let us discuss this 2 wattmeter method. So for that, let us try to draw the first of all star connected system, three-phase, three-wire system. पहले कंप्लीट करो इसको. Suppose this is your A phase, then this is your B phase, and this is right. And these are the three loads. Let us consider it as L1, L2, L3, or LA, LB, LC, whatever you want to consider. Now, here this is the symbol of a wattmeter. All of you know that. This is a wattmeter representation. So here you have two coils. The current coil, this is your current coil, and this is your pressure coil or voltage coil, right? So the current coil of the 2 wattmeters, this is suppose wattmeter 1, and this is your wattmeter 2. So the current coil of these 2 wattmeters are connected to any of the lines, right? जैसे कि any of the lines का means कि एक line है ये या phase है ये, तो current coil series में connected है line के. Similarly here also in phase B, right? And the voltage coil or pressure coils are connected between the corresponding lines and the third line. मतलब जो corresponding line था वो जैसे कि A and B phase and the third line in which the wattmeter is not connected, right? So suppose these are the currents IA, then this is your IB, and this is your IC in the three phase. These are the three phase currents, right? So if we calculate, if we write the expression of total instantaneous power supplied to the load, right? Means पहले ये calculate करो कि what will be the instantaneous power recorded by W1, that is wattmeter 1. ये क्या होगा बताओ? बताओ क्या होता है? This will be पावर. क्या होता है? पावर वोल्टेज इनटू करंट, राइट? तो इस फेज में हम लोग कैलकुलेट करना चाह रहे हैं इंस्टेंटेनियस पावर, राइट? देन this will be simply the current flowing through this current coil is IA, and what is the voltage across this voltage coil or pressure coil? This will be the difference of these two voltages, that is VA minus VC. VA minus VC. So this is the value of the instantaneous power recorded by wattmeter 1, W1. Similarly, the instantaneous power recorded by W2, this will be equal to how much? The current flowing through the current coil of wattmeter 2, that is IB, and voltage across these two coils, that is VB minus VC, right? So therefore, total instantaneous power measured by W1 and equal to, that is W1 plus W2 is equal to IA VA minus VC plus IB VB minus VC. So just write it. This will be IA VA plus IB VB, and here you can take minus VC as common, and this is IA plus IB, right? ठीक है? So now if you apply KCL at this neutral point, this is the neutral point suppose, तो क्या होगा? This will be IA plus IB plus IC is equal to 0 at this node or neutral point. सारा का सारा KCL क्या कहता है? याद करो KCL का क्या स्टेटमेंट था? ठीक?
Current entering a junction is 0.
Right. Current entering to a junction should be equal to current leaving the junction, or alternately you can also define it. At any node, the summation of the total current is equal to 0. Both signify the same thing. So from here you can write IA plus IB is equal to minus IC. Therefore, W1 plus W2 is equal to IA VA plus IB VB plus IC VC. This is the total power measured by total instantaneous power measured by these two wattmeter. Now, you tell me what should be the total instantaneous power supplied to the load. इस circuit में what should be the total instantaneous power supplied to the load? Let us represent it by capital P. So this will be simply equal to, directly you can say that for phase A the instantaneous power will be VA-IA. Then for phase B it will be VB-IB, and for phase C it is VC-IC. ये होना चाहिए total power, instantaneous power that will be supplied to the three-phase load connected in a star, and the same thing we are getting from here also using the 2 wattmeter method. It means that 2 wattmeter method is sufficient. 2 wattmeters are sufficient in order to measure the total power in a three-phase circuit, whether the load is balanced or unbalanced, right? So if the load is a star connected, it should have no neutral connection. That is, it should be a three-phase, three-wire system. And if it has a neutral connection, that is, suppose if we want to measure power in a three-phase, four-wire system, then it should be exactly balanced, so that in each case there is no neutral current flowing through the neutral wire. Otherwise what will happen? मतलब क्या कहना चाह रहे हैं, समझ में आ रहा है कि if you want to measure the total power in a three-phase star connected system using 2 wattmeter method, then there should be no neutral connection, means no neutral wire should be there, right? But even if the neutral wire exists in a three-phase system, that is, if it is a three-phase four-wire system, and if you want to measure the power using 2 wattmeter method, then in that case the neutral current should be equal to 0. तो कब होगा 0? When your system is perfectly balanced, right? Balanced load अगर है system में तभी वो 0 होगा, नहीं तो क्या होगा कि you will have this type of relationship, IN plus IA plus IB plus IC is equal to 0, right? मान लो कि इधर से IA आ रहा है, इधर से IB, इधर से IC, and this is your IN. So this will be the KCL equation in this condition, right? So under certain conditions, one of the wattmeters may read backward reading, giving you a negative value. So you can tackle this situation. You have to just interconnect any of the current coil or phase coil. Interchange the connection of either the current coil or the voltage coil, right? But not both. ये समझ में आया पूरा कैसे करते हैं 2 wattmeter मेथड से? हेलो?
Yes, sir.
Yes, sir.
Hello? Okay. Thank you. So now we will discuss about the calculation of power factor for a balanced load, right? Calculation of power factor for a balanced load. So you know that load may be of any type. Any means mainly 3 types: lagging power factor load, leading power factor load, and unity power factor load. So let us first of all consider the lagging power factor load, because most of the loads in your system is lagging in nature. So lagging power factor load. So in case of lagging power factor, what will happen? The phase currents, means phase current क्या है यहाँ पे? IA, IB and IC. In a star connected system we are talking about. Your phase current and line current both are same. So phase current IA, IB and IC will lag behind their respective phase voltage by some angle. Let us consider that angle as phi. So let us try to draw the phasor diagram. So first of all, you will have to consider the reference axis. So let us consider this Vn An on the reference axis. Then this will be the another phase voltage, that is Vbn, and this is your Vcn, right? So what I have told you, in case of lagging power factor load, the phase current will lag behind their respective phase voltage by some angle. तो यहाँ से जो respective phase current है, suppose IA होगा, तो ये सम एंगल फाई से सपोज लैग कर रहा है VAN से. सिमिलरली दिस विल बी योर ICN, same angle, because we have considered a balanced condition, and here it will be IBN. This is again phi, right? So this is for a lagging power factor. You please note down that this phasor diagram we are drawing for a lagging power factor load. Now, the power indicated by the wattmeter in an AC circuit is equal to the product of voltage across the voltage coil multiplied by current through the current coil into the cosine of the angle between the voltage and current in that coil. Means if we want to calculate the power by wattmeter, then power indicated by wattmeter in AC circuit can be written as the product of voltage across the voltage coil or pressure coil into current through the current coil into cosine of angle between voltage and current, right? Respective phase के बीच का जो phase difference होगा वो. So now let us consider here, let us consider for this system considered, the system is balanced, that is IA is equal to IB is equal to IC. So this will be equal to the phase currents will be equal to the line current, and the line currents or line voltage here, you have VAB, VBC is equal to VCA, that is equal to VL. We have considered here just the magnitude, because phasor relationship we are already drawing in this phasor diagram. So for the previous case, जो अभी हम लोग यहाँ पे देखे थे इस सर्किट में जो वॉट मीटर था, so this watt meter suppose reads P1 power and this reads P2 power. So what will be the value of P1? P1 will be equal to VAC times IA into cosine of angle between VAC and IA, right? तो क्या हुआ, power reading of wattmeter 1, reading of W1, suppose P1 A will be equal to VAC IA and cos of angle between VAC and IA. तो ये अब पता करना पड़ेगा कि VAC और IA के बीच का कितना फेजर एंगल है. So before that you will have to calculate the VAC. So you know that VAC is basically your VAN minus VCN, right? तो अब फेजर डायग्राम से पता करो VCN इधर है इस साइड, इसका जस्ट अपोजिट लेंगे. So this will be minus VCN. Now the phasor summation of these two will give you VAC. Now this angle you already know, this is phi, right? अब ये एंगल क्या है ये बताओ, ये एंगल कितना होगा बताओ. Means VAC और
30.
VAN के बीच का एंगल, right? This will be 30 degree. So now you can say that what is the angle between VAC and IA? कितना होगा this angle, ये कितना होगा? This will be simply 30 degree minus 5. ठीक है, तो P1 is equal to VAC we have considered, VL IA is equal to IL cos 30 degree minus 5. Now similarly, if we calculate the reading of W2, that is wattmeter W2, let us represent it by P2. So it will be equal to P2, देखो इस सर्किट में क्या होगा, VBC into IB, that is VBC into IB and cosine of angle between VBC and IB. तो VBC और IB के बीच में पहले निकालना पड़ेगा कि क्या होगा एंगल, राइट? सो IB you have here, IB, ये IB है, ये IC है सिंपली. तो बताओ क्या होगा, यहाँ है तुम्हारा minus VC, so the resultant of these two will give you VBC, and again this angle is 30 degree between VBN and VBC, and the angle between VBC and IB will become 30 degree plus 5, means this complete angle 30 degree plus 5, right? So we have obtained the reading of wattmeter 1, that is P1, and reading of wattmeter 2, that is P2. So total power, this implies P1 plus P2 will be equal to, सॉल्व करोगे इसको कुछ तो ये भी इसको इस फॉर्म में लिख दो, VL IL cos 30 degree plus 5. So P1 plus P2 calculate करोगे, then you will get √3 VL IL cos 5. So this is the total power in any three-phase circuit. All of you know that, right? तो इस तरह से हम लोग जो है फेजर डायग्राम के थ्रू भी जो है सो टोटल पावर कैलकुलेट कर सकते हैं. Previously we have done it with the help of circuit diagram. Now we have done it with the help of phasor diagram. Now if you want to calculate the power factor of the load, lagging power factor load, then let us calculate P1 minus P2 also. P1 is known to you, P2 is known to you. So when you will calculate this P1 minus P2, you will get VL IL sin phi. यहाँ से अगर कैलकुलेट करोगे तो ये कर लेना तुम लोग कैलकुलेट. So therefore, using this equation, suppose 1 and 2, you can easily calculate the expression of, suppose tan phi. Tan phi will be equal to how much? नीचे √3 होगा तो √3 times P1 minus P2 divided by P1 plus P2. So if tan phi is known, then you can easily calculate the value of power factor cos phi, right? तो ये जो है पूरा कैलकुलेशन है यूजिंग 2 वाटमीटर मेथड. नाउ यू हैव टू डू वन थिंग, ये असाइनमेंट है तुम लोग के लिए कि डू द कैलकुलेशन ऑफ पावर as well as power factor for leading power factor load. ठीक है, अभी हम लोगों ने क्या कंसीडर किया प्रीवियस स्लाइड में? वी हैव कंसीडर्ड लैगिंग पावर फैक्टर लोड, मींस करंट ऑफ ईच फील्ड. हाँ, यस, करंट लैग कर रहा था. नाउ इन दिस कंडीशन फॉर लीडिंग पावर फैक्टर लोड, करंट विल लीड द रिस्पेक्टिव फेज वोल्टेज बाय सम फेज एंगल, सपोज 5. तो उस केस में क्या फेजर डायग्राम होगा, फिर कैसे निकालेंगे P1 P2 टोटल पावर P1 प्लस P2 एंड देन पावर फैक्टर, दैट यू हैव टू डू. ठीक है, आज टाइम हो गया है, कुछ ज्यादा ही टाइम हो गया है, तो आज के लिए बस इतना ही है. किसी को कुछ क्वेश्चन है तो
Excuse me, sir.